perpendicular lines today. What does it mean to be perpendicular? Who knows what that word means? Alyssa? It's more than just a line that intersects, but it does include intersection.
Lines that intersect at a 90-degree angle.
Your hand would have been useful if you wanted to answer. What's up, Mike? Yeah. We'll talk about that in a second. So, I know he didn't. We'll get there in a second. Lines that intersect at a 90-degree angle. Yeah, but I called on Jordan to tell me, and then you said it out loud. Your listening skills are on par. All right, so we are going to be writing equations of lines that intersect at a 90-degree angle. So do you think they're going to have the same slope like parallel lines had yesterday? Unfortunately not. We know from yesterday that parallel lines just translate or shift up or down, right? And that's why the lines stay the same slope. That's why we don't have to change the slope. It's because they just stay in the same direction. They go in the same direction. With perpendicular, you're going to look at it as a rotation. So there's going to be a rotation involved. So if you look at these two lines, f of x and g of x, what do you notice about these two lines? They do intersect. Intersect at 2, 0, right? What else do you notice about these lines? What do they look like to you? Yes. Crossing. It kind of looks like they're crossing at a 90-degree angle right here. That means 90 degrees when I put that square in. So intersect at 2, 0 at a 90-degree angle. So what we need to do now is figure out what that means by comparing their slopes. So we need to figure out what that means now by comparing their slopes. So these 3 rows, find the slope of f of x, real quick. These 3 rows, find the slope of g of x. So go ahead, find the slope, and then we'll talk about it. So f of x slope, u3 are g of x. You can talk to the people around you. Some of you aren't, well, you guys are doing different lines, so that doesn't work.
Wait, I'm doing f of x?
Yeah.
Oh, I was just doing g of x.
Talk to each other if you want to check to see if you're right, because I'm going to call on someone.
Negative.
Wait, what are you doing?
Alright, go ahead.
I have a question, and I'm not gonna say it out loud. But like, is it like the same x-intercept with different slopes?
The x-intercept doesn't even have to be the same. It can be the same.
Okay.
The slopes are going to be different, but there's something specific about the slopes. That's one of the things. There's 2 things. All right. Josh, what did you get for the slope of f of x? So it's a positive slope?
Oh, it's negative.
Yeah. Do you guys see it? It's going downhill?
Yep.
So it's going down 1, right 2, which is a slope of negative 1/2. Connor, how about g of x?
It goes up 2 and then over 1.
So what is that slope? Rise over run.
2 over 1.
Okay. You're fine. 2 over 1 is just the same thing as 2. I'm going to leave it like this for a second, though, to make it more apparent to you guys. What is something you notice about these 2 slopes? What is something you notice about these 2 slopes? Kaylee Levine?
They're basically like flipped.
Okay, there is a flip. They are flipped, but there's one other thing you should notice. So the first thing is they are flipped. Jordan. Signs are opposite. This is known as an opposite reciprocal. So to be perpendicular, you need to flip it, which is a reciprocal, and change the sign, which is the opposite part of it. So perpendicular, which is this symbol here, has a little bit different thing going on than parallel. Parallel, we could just take the slope and keep it the same. But with perpendicular, we have to flip the signs, or flip it and change the sign, which is known as an opposite reciprocal. This is formed by a rotation. You'll notice this is rotated 90 degrees. Do you see that?
Yeah.
It's rotated 90 degrees. That's what that is there. And we'll talk more about rotations and translations in geometry next year. So I'm just trying to get you guys to hear that vocab for the first time now rather than the first time next year. Okay, when you're ready, go ahead and flip to the next slide. What's up, please? That might be an issue because it's going to be a hard lesson. But I'll get you this stuff. Try to be here if you can. If you have anything to do with it, okay? All right, we have issues every time we flip the pages, guys. We have issues every time we flip the pages. Please stop. All right, perpendicular. That's what that symbol is there. Lines are two lines when graphed intersect to form a right angle. The slope of perpendicular lines are opposite reciprocals, meaning if the slope was b over a, positive b over a, the perpendicular slope would be negative, and then you flip a and b. You flip the denominator and the numerator. So we're going to determine if these lines are perpendicular. Mike, why are you out of your seat? Sit. All right. So, perpendicular, just like yesterday, to determine if two things are perpendicular, you first need to get it into it does not matter if they have the same y-intercept. The only thing that matters is that their slopes are opposite reciprocals. They could have the same or they could have different. It doesn't matter as long as their slopes are opposite reciprocals. After we get it into slope-intercept form, we're going to check to see if the slopes are opposite reciprocals. Go ahead and get that written down. Is line M perpendicular to line N? Justify your answer. Riley, what do we have to do first with line M in A? So you don't do. So my slope isn't 1. Is my slope 1?
No.
I'm just trying to trick you. No, it's not 1. This is in standard form. What you were doing was right. So we subtract x. A lot of you guys will tell me that my slope is 1, but it's not in slope-intercept form, is it? What do you have to do next? I'm sorry. I just like to make sure I address the issues that a lot of you guys do. You were doing a great job. You're fantastic. So my slope here is negative 1/2. How about that other one there, Alyssa? What do I have to do? So the slope isn't 3? No, the y is not isolated yet. Be careful. See, I didn't just do it to you, so it's not just you. You just happen to be the first person. So do we have perpendicular lines here? Are they perpendicular?
No.
Okay, it has to be two things. It has to be two things. Are they opposites?
No.
Yes, they are opposites. They have different signs. One's positive, one's negative. So we said yes to one of them. Are they reciprocal?
No.
No, they're two different numbers. So it has to be yes to both of those things. So these are not perpendicular. Because they are not reciprocals. They're just opposite. They have to be both opposite and a reciprocal. Although you're drawing a really pretty picture.
Thank you. I already wrote
Okay,
it
you already
down.
wrote it. Good. All right. Sure. Brian. Line M in part B there. What do you have to do? So what are you going to... 1 minute.
Wait. You have to divide by 3.
Yes. So we have to divide by 3. So we have our slope there. Lamar, is 2y equals negative 3x plus 21 in slope-intercept form? This one right here. Is that in slope-intercept form? No. So what is attaching the y and the 2? Is that addition, subtraction, multiplication, or division? Be careful. That's multiplication. What's the inverse of multiplication?
Division.
So what are we going to divide by on both sides?
2.
Good. All right. Emma, are these perpendicular? So they are, one's positive, one's negative, right? So they're opposites. Are they just flipped?
Yeah.
Yep, so they are perpendicular.
Good job, Emma. Why did you put an upside down T?
That's what purpose.
That's the symbol for perpendicular.
Oh.
You might have been drawing one of your pretty pictures when I said that.
I was drawing a giraffe. It can be what I wanted.
If you just
Is it really a giraffe?
Okay, guys, please focus. I get that we're done with the slides. That doesn't mean you need to be done talking. Or start talking, whatever I'm trying to say here. Please stop talking. Okay, so we're going to get into examples from, like, yesterday as well, but this time with perpendiculars. And some of you are writing it down still, so I want to wait until everybody's there.
Don't you gotta change the slope here? She taught us to change the sign and flip the slope.
That's it. You're just comparing to see if they're perpendicular. You will in the next example. That's
supposed to change it there.
Not there. These are just comparing the two lines to see if they're perpendicular. When you're going to write the second equation, then yes. So the next example there. You're mixing up different types of examples. All right. Write an equation of a line that passes through 3, -2 that is perpendicular, so make sure you're reading directions on your homework, to the line y equals -3x plus 22. We're going to go through those same steps we went through yesterday with parallels. So first thing, Cassie, is this equation in slope-intercept form? Yes. So do we have to get it into slope-intercept form? Okay, Cassie, what is the slope of that? Okay. So the next thing you have to do is take the slope from that line. That's all you need from that line. From there, Riley, what is the perpendicular slope of -3? That would be parallel if it's the same. What did we talk about today, perpendicular being? Okay, opposite. What other piece did you forget? Okay, guys. Why is it 1/3? Exactly. That's why you don't just tell them the answer. Do you understand that? So look at the slide above you there. What does it tell you to do with the slope after the definition of perpendicular? It says the slopes are what? Opposite reciprocal. Do you know what the word reciprocal means? What does it mean? It means you're flipping it. So you're flipping this piece of -3. So you did the opposite part. You made it positive, right, by saying 3. But if you were to flip 3, why is it 1/3? What is 3 over? 1. Right. Even though we don't say this is the same as -3 over 1, right? Yeah. So you change the sign and you flip it. You have to do both things. So change the sign and flip it. Does everybody get that? Do we care about that equation anymore? No, this equation doesn't matter. We only cared about it for its slope. So we're going to use our perpendicular slope of 1/3 and the point 3 comma 2. So what form do we have to start in, Jordan? Why can't we start in slope-intercept on this one?
Because you don't know the y-intercept.
We do not know the y-intercept, so we're going to start in point-slope form. Jana, put it in slope-intercept form for me, or point-slope form for me, I'm sorry. Good, and again, if you don't know how to do the fraction...
Yeah, the order bears 3 negative 2.
Oh, I wrote it wrong. So, Jana, what would the 2 be? Yep. Thank you, guys. Thank you for telling me before we got through the whole problem. So, yeah. So, it's good that you guys noticed those things. So, we get y plus 2 equals 1/3 times x minus 3.
Can I go get some paper towels? She spilled her water.
Tanara, you can get them.
Oh, she's trying to be nice.
All right. If you need to run to the bathroom, you can too, Tanara. Grace, put that into slope-intercept form. Guys, stop. First, what do you have to do? So you get what? Okay, and then what did you do, Grace? Good. You told me the right answer. I just wanted to do the work. So you'll notice that the slopes are just opposite reciprocals. So one's positive and one's negative. 3 over 1, 1 over 3. The y-intercepts don't matter. They could be the same or they could be different. You could if it does tell you that, but on your homework I want all of them in slope-intercept form anyway, so I'm going to do this. Does this make sense? All right. Questions so far before we get to example 3? When you're ready, go ahead and flip so I can know that you're there with me.
Almost done.
All right. So write an equation of a line that contains negative 4, 8, and is perpendicular to 2x minus 3y equals 1. Emma, is the equation in slope-intercept form? Okay, so can we just determine the slope then? What do we have to do then to get into slope-intercept form, Emma?
Subtract 2x.
Thank you for cleaning it up, Tanari. Emma, what do you do now? So a negative and a negative is a positive, so that's y equals positive 2/3 x. A positive and a negative is a negative, so that would be minus 1/3. Lamar, what is the, after you write this down, tell me what the slope of that line is, okay? So go ahead and get it written down and then tell me what the slope of the line is that we just found. Yeah, what is the slope of this blue line right here? Y equals 2/3 x minus 1/3. You were right.
2/3.
Yep, it's the number in front of x. So your slope is 2/3. Connor, what is my perpendicular slope?
Negative 3 over 2.
Good. You notice he made it opposite. Opposite of a positive is a?
Negative.
And he reciprocated it. It's an and. You have to do both. So do we care about this line anymore? Nope. However you want to say it, that is fine. So we have negative 4, 8 as our point. Lexi, what form do we have to start in?
Point slope.
We do not know the y-intercept, so that's why Lexi said that. Justin, do you want to put it in point slope for me? Go ahead.
Y minus a equals negative 3 over 2x plus 4.
Okay, again, you should have a calculator out if you don't know how to do the fractions. So, Miguel, what would you do first to get this into slope-intercept form? Okay, can you put negative 3/2 times 4 in your calculator for me? tell me what you get out?
-3.
It wouldn't just be -3. How did you put it in your calculator?
I put over 4.
That's why. That's why I wanted to look at it. There you go. So what is it? And then what would you have to do, Miguel? Yeah. Josh, did you have a question or do you just want to say the answer?
No, I just want to say
Okay. So again, you have your perpendicular line. It has an opposite reciprocal slope, 2/3 and -3/2. The y-intercepts could be the same. They could be different. It doesn't matter. What questions do you have there so far before we get into another example? Yes, Jordan. Go ahead. All right. Just wait a second, though. All right, write an equation of a line that passes through 4, 3 and is perpendicular to the line y equals 4x minus 7. So you see now that I've pulled those questions off, right? Remember I told you I put those on there at first to get you used to those questions. I did the same thing on the worksheet today and I pulled them off for the last few examples, right? Just to get you used to what you need to do. So Brian, what is the first thing I need to do here? So if you need to look back at a previous example to see what the first question is, you can. So we don't have to change it. It's in slope-intercept form. So Brian, what is the next thing you have to do then? What does question 2 on there say?
What is the slope of the given line?
What is the slope of that given line, Brian?
4.
4. Okay. What is the next thing you have to do, Janari? So, not yet, because we need to do perpendicular. If it was parallel, you would use the same slope, but are we dealing with parallel lines? So what do we have to do? We need... Good. So what is the perpendicular slope? Yeah, so it was positive, so now it's negative, and now it's also a fraction, boys. So do we care about this line anymore? No, so we have 4, 3 here. Hey, Josh, what form do you have to start in? So can you put it in point slope for me, please?
y minus 3 equals -1/4, and then times x minus 2.
Good. Kaylee, what do I do now? Good job.
You get a thumbs up, Taylor.
All right. Then what, Kaylee?
And then you add 3 to both sides. You get -1/4x plus 4.
Good. Questions on how to do that without those questions there? If you need to, just pull your notes out and look at the questions you have to ask yourself to get to the right answer.
I redid some homework last night.
Okay, guys, you have 2 more slides. Let's go. You got to stop your talking. And then you'll get the homework. Okay, write an equation of a line that is perpendicular to the points -4, 6 and -10, -3 that contains the point 9, -2. What do you think we have to do here?
Ooh.
Colin?
Ooh. Find the slope through the first order pairs and then plug it into point slope form with the last little points.
Okay, so we're going to find the slope of the first ordered pairs first. That was really good.
Good job.
So we do -3 minus 6 or over -10 minus -4, or you can stack them if you like to do that better.
Yeah, I like that.
That is completely fine. So that's -9 over -6, which is +3 over 2. Okay, what word is it that is important in this sentence? What is the important word, Jordan? So does that mean we keep the slope the same? No, what's my perpendicular slope then, Jordan? Opposite reciprocal. -2 over 3. So all we care about is that slope and the other point given to you. So we start in point slope form. Lamar, can you put it in point slope form for me? So the point is down here. Okay.
Y minus 9.
Be careful. So this is x1 and y1. So
Y plus 2
good. Equals.
equals -2 over 3.
Perfect.
X minus 9.
There you go.
You're on a roll today.
All right. Mike, get into slope-intercept form. What's negative 2/3 times negative 9? Mike's going to do it in his calculator, guys.
Yeah.
Come on, folks. -4. Yeah.
Seal of approval.
How did you type it into your calculator?
Oh, wait.
You times 6 instead of times 9.
Oh.
Guys, telling you it's the operator error. There you go. But a negative and a negative is a...
Seal of approval.
All right. Mike, what do you do last there? Josh, if you need to go to the bathroom, you can.
Oh, yeah.
All right. We have one more problem to do. That's because this class is so exciting, I know. Any questions before we do the very last graph? What do you guys think your biggest mistake is going to be on your homework?
I'm not making any mistakes.
Positive or negative.
Forgetting to switch the sign? Okay. Forgetting to make it or just the fractions in general?
Fraction the entire problem.
Reading the entire problem. What do you need to make sure you do with these types of problems? We need to know the directions, because if it says parallel, what do we need to do with the slope? But if it's perpendicular, you have to... We are. I'm just talking through some stuff with you guys. So parallel means same, and then perpendicular means flip it and change the sign. So make sure you guys are reading those directions and understanding what it's asking. So it says write the equation that is perpendicular to the given line that goes through the point 1, 2. So what is the first thing we need to do? Find the slope of this line. Do you see how there's 2 points already given to you there?
Yeah.
So this goes up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5. This is a fantastic slope of 6 over 5. Is it positive?
Yeah.
Oh, yeah.
Justin Powers, what is the perpendicular slope?
-5/6.
Okay, what form should we start in? Point slope. Emma whispered it under her breath over there. Oh, you don't have to apologize.
Good job, Emma.
Brian, put it into point slope. That's the current slope, and we're not writing a parallel line, we're writing a perpendicular, so. Okay. Minus what?
1.
Yeah. So 1 times anything is itself, so that one's pretty easy. So that would be positive 5, 6. Go ahead and put in your calculators 5, 6 plus 2. If you do not know how to add that without a calculator. So go ahead and do 5, 6 plus 2 in your calculators. I want you guys to try it. I'm going to give you a second to try that. And I'm going to call on somebody. So do 5, 6 plus 2. Okay, what do I add to the end there? Cassie, what is it at the end?
17 over 6.
So 17 over 6 is the same thing as 2 and 5, 6. So if you got 2 and 5, 6, that's completely fine. All right. Questions for me before I hand out the homework? What should you be doing?